These are the rest of the notes for chapter 15 that we did not finish in class. I just want to back up a bit, and if you look at the textbook, um, I want to go back to the categories of pollutants from 15.2. And since these were not in the notes sheet that passed out, I just want to reiterate that you should be familiar with all the different categories of pollutants and be able to give some examples of these particular categories. Infectious agents, scrolling down, and the book just gives you a complete list. Toxic heavy metals, mercury, toxic pathways, biomagnification, how substances or the accumulation or increase in concentration of a substance in a living tissue as it moves through the food web. Um, Mercury is a perfect example of that. Scrolling down again, organic compounds, synthetic organic compounds and organic compounds, things that are synthetically made from pharmaceuticals or pest controls or food additives to naturally occurring organic compounds can potentially be hazardous. POPs, persistent organic molecules, carbon-based, they're polluting and toxic. These are some of the examples of some POPs. Herbicides, DDT, the insecticides, herbicides, PCBs, dioxins, which we just are not sure what the side effects are. Hormonally active agent, which causes changes in reproductive abnormalities or development. Things like DDT cause diffuse into eggs and cause deformations or abnormalities in the reproductive organs of whatever organism we're talking about with that egg. But a closer look at 15.3, I mentioned this in class, looking at dioxin, the big unknown. We just aren't quite sure. We all consume dioxins, but we're just not quite sure what effects they have on humans. Essentially, what is that level where it's going to become toxic? It's a kind of a big problem. Radiation is another form of pollutant. Thermal pollution from power plants is another form. Particulates, things that we breathe in, dust, asbestos, a substance used, a mineral we used mainly for insulation. Electromagnetic fields, which again we still don't know exact studies when it comes to things like cell phones. Noise pollution, voluntary exposure to things like cigarettes and tobacco. Right, these are all the different categories that you should be familiar with and should be able to list and give examples to. So I'm going to go back to the PowerPoint here and start, just rewind a little bit and look at this dose response curve. And let me fix the slide here to move it full screen. There we go. So again, for any particular chemical, there may be a whole family of dose response curves. The ED, the effective dose, the toxic dose, and the lethal dose are all kind of connected. You know, which dose is of interest depends on what's being evaluated. Are we looking at killing insects versus pesticide residue? And again, as we talked about in class, there may be an overlap of the particular curves. What might be effective for some could also be toxic to others. And if we look at the measure of relativity or relative safety of a particular drug is the therapeutic index. The greater the therapeutic index, the safer the drug. That's the ratio of the lethal dose 50 to the ED 50. If we look again at this particular graph, we have overlapping that occurs. The ED 50 for some of the population, the ED, the effective dose could be the toxic dose for some. For some, the toxic dose becomes lethal for some. There's always some overlap between the two doses, and that's what is the big concern when we look at this particular graph. But moving back to threshold effects. Right? The threshold is just a level below which no effect occurs and above which effects begin to occur. So if a threshold exists, then a concentration below the threshold is safe. If there's no threshold dose, then even the smallest amount has some negative toxic effect. So the problem with looking at the thresholds is that it's difficult to account for these synergistic effects. Remember, synergism is the effect of the chemical individually is not as strong as the effect as the chemicals combined. So we have, again, the threshold of toxin B up to 50%, there's no threshold, but once we get above that, there's an effect. Go back to this chart again. So you're looking at toxin B, where it just depends on the toxin. Right here, at this point, there's no threshold, but once you cross that concentration, there's going to be some level effect. Well, toxin B, the percent, it's a little lower. Right here, there's no threshold. Once you cross that threshold, there's a response. Depends if you're looking at a positive or negative response in that particular drug. So if we move on to ecological gradients. Ecological gradients are just changes in vegetation with the distance from a toxic source. So a weedy species, for instance, adapted to harsh conditions may be closer or farther away trees and shrubs from that particular toxic source. So you do have vegetation that will change, that will adapt to its environment. If you look at tolerance, a couple more things left in the notes. Tolerance is just the ability to resist or withstand the stress resulting from whatever you're exposed to. That can result from a behavioral, physiological, or genetic adaptation. Of course, a behavioral tolerance is a change in behavior. So learning, for instance, to avoid traps. Common characteristic of animals. Learning, even fish, learning to avoid traps. All right, when you look at a physiological tolerance, the body just makes an adjustment to tolerate higher levels of the pollutant. So you have some sort of internal transport that's part of the body where it's not harmful, such as in fat cells. So your body makes a response. And sometimes you make a genetic tolerance. Some individuals in a population are naturally going to be more resistant to the toxin than others. For instance, mosquitoes can be resistant to DDT. Right? Antibiotic resistance, we talked about in class that there's a antibiotic resistant strand of tuberculosis. Things adapt to the environment. If you look at acute and chronic effects, an acute effect is one that occurs soon after the exposure, usually to large amounts of the pollutant, and a chronic effect takes place over a long period of time. So a result of an exposure to low levels of the pollutant may be something you breathe in over time that eventually may cause cancer. Cell phones, this idea over a long period of time, are we going to have problems with our brain? Asbestosis, or breathing in asbestos, might, in the short term, not have that much of an effect, but in the long term, may cause asbestosis or a form of lung cancer. And the last part of this chapter is assessing risk assessment. And risk assessment is just the process of determining a potential adverse environmental health effect to people exposed to pollutants or potentially harmful materials. So we're looking at assessing, including first identifying the hazard. It's kind of a four-step process. You identify the hazard, you look at the dose response assessment, the exposure assessment, and then you characterize the risk. And risk assessment is difficult to do. These 4 steps are difficult because they're costly and sometimes controversial. How do you figure out the dose response? Well, you're going to have to test it on certain individuals or certain animals. But overall, when it comes to your risk management, you're integrating the assessment of risk with different technical issues, legal issues, political issues, social, economic issues. You integrate uh, um, all these issues into deciding how to best come up with a solution to this step. Um, it really concludes chapter 15. I'd recommend again, you go back and make sure you have all the information in the notes. You're able to make categories, or you're able to go back and look at the categories of all the pollutants. On the study guide that I handed out at the beginning of the chapter has a section where of all the terms that you should know. I'd go back and make sure that I've highlighted or made flashcards, but understand the terminology that is used. I would go back and read the summary. And a summary is a good way to, put all the pieces together. Part of the textbook. If I end my show and I go to, and again, that study guide came right from the textbook. Read the summary. Put some things together. You have key terms. These are all the key terms that you should be familiar with. And in these key terms, you have all the different, or most of the categories of the pollutants. I would also, something very important is looking at the dose response curves. These curves are going to be on the AP exam. You're going to have to interpret that on our test. Go back and make sure that you understand how these kind of work. If you're not sure, please come see Mr. Matthews. But that does conclude the chapter 15 notes. I'll post the PowerPoint on Blackboard as well. Just make sure that when you're finished, you go back and review your notes. So again, see Mr. Matthews with any questions, and we will see you next class.